Hello and welcome back to Ganesh Institute channel. So in today's video we are going to discuss about indeterminate forms. That means solving a limit when it is in the form of infinity by infinity, 0 by 0, infinity minus infinity form and so on. So let's take up some examples and understand what does it mean. So here the question is given to you that you have to evaluate limit x tends to 0 for 10x log x. So how you will solve it? Because if you see, if you directly put x as 0, 10 0 is 0 and log 0 is something which is infinity. So this is a 0 into infinity form, right? So again indeterminate form, how you will solve it? So what you can do to elaborate, let's say just apply some techniques, some formulas. We have log x here. We can write 10x as 1 upon cot x, correct? Now, if we do L'Hopital rule here, if we apply L'Hopital rule, I hope you have already watched my previous video in which we discussed about this thing. So you have to differentiate numerator and denominator separately. So limit x tends to 0. Derivative of log x is what? 1 by x. Derivative of cot x is what? Minus cos x square x. Correct? Now you can bring cos x square x up, so it will make sine square x by x. Correct? Now again if you substitute 0, it is forming sine 0 is 0, 0 by 0 form, right? Indeterminate form. So what you can do? Again apply L'Hopital rule. So limit x tends to 0. If you apply here, minus sine square x is given, right? So let's assume sine x is some variable t. So t square, derivative of t square will be 2t and t is what? Sine x. Now whichever has been assumed as t, you have to do the derivative of it. So derivative of sine x will be cos x. Correct? So you have got minus 2 sine x cos x, and in denominator you have derivative of x which is 1. Correct? Now if you apply the formula, like directly put the x tends to 0 here, the concept. So sine 0 is 0, cos 0 is 1, so you have got 0. 0 by 1, which is a determinate form. Correct? So in this way you can calculate the limits. Again take up one more example. Here what is given to you? Limit x tends to 0. So if you substitute 0 in place of x, you will get 1 by sine 0, which is 0. So 1 by 0, that means infinity form. Here also 1 by 0. So infinity minus infinity, again this is indeterminate form. Correct? So in order to get the right value, what you can do? You just apply. Firstly, try to simplify this. You can have LCM, then cross x minus sin x. Correct? Now, what you can do, you can apply L'Hopital rule because it is still the same thing, 0 by 0 or infinity minus infinity. So if you apply here derivative, this will be 1. Derivative of sin x will be cos x. And then you have to apply here x sin x, product rule. Right? You are applying L'Hopital, so you will differentiate numerator and denominator separately, right? So how you will apply product rule? X as it is in derivative of sin x is cos x plus derivative of x is 1 and sin x as it is. So x cos x plus sin x, right? Limit x tends to 0. Now try to apply 0 so that we can check whether L'Hopital is required one more time or not. So 1 is okay, cos 0 is 1. So 1 minus 1 is 0. And then you have here 0, sine 0 is 0. Again, this is indeterminate form, right? So we have to apply. We can't say this is the answer. So we have to apply again what? L'Hopital rule. So it will be 1 is nothing. Derivative of 1 is 0. So cos x is minus sin x and minus minus plus sin x. Divide by x cos x. So if you apply product rule again, derivative of x is 1. So cos x as it is. X as it is. Cos x derivative is minus sin x. So you have got cos x minus x sin x. And here you have got sin x. So derivative of sin x is cos x. Right? Now apply 0. So if you will put sign 0 is 0, here cos 0 is 1, cos 0 is 1, 1 and 1 2, and this is 0. So 0 by 2 is something which we can have a finite term. Correct? So in this way you can apply limits. Let's take up the last example. Now in this sort of question what you have got is power raised to power. Correct? The function raised to power function. So if you substitute pi by 2 in place of x, you will get sine pi by 2 is 1 raised to power 10 pi by 2, which is infinity. So you will get some of the form like 1 raised to power infinity, 0 raised to power infinity, or infinity raised to power 0. In these sort of questions, you have to apply logarithms. Okay, how you will apply? So let's say you have u raised to power v. Consider it something so that you can take log to both sides. So this will become log u. V will come as coefficient and it will become log u, and then you can easily apply, if it is in denominator form, L'Hopital rule or something. But beyond this you can think like, let's say we have assumed this as y, so we are taking log. Now this will become, limit will be as it is, but the power will come as coefficient 10x log sin x, right? Now if you see here, if you substitute pi by 2, so sin pi by 2 is what? 1, log 1 is 0, 10 pi by 2 is infinity. It will be infinity into 0 form, correct? So we can't consider this. So what we will do? We can have L'Hopital rule in place. So we can mark it as log sin x, and we can mark 10x as 1 upon cot x, correct? Now you can apply L'Hopital, differentiate numerator as well as denominator. So if you see, you have to solve log sin x. For log x, you have 1 upon x, and whatever you are assuming as x, its derivatives. Derivative of sin x is cos x, correct? So you have got cos x by sin x. From here you have differentiation of cot x is minus cos x square x. Limit x tends to pi by 2, right? So one sign will be cancelled with one sign because cos x is 1 upon sin, correct? So you have got log limit x tends to pi by 2, cos x by minus cosec x, or you can say minus cosec x can be written as sin x here, correct? Just bear with me. So we can write it as minus sin x in numerator, correct? So this is your log y. Now assume you have x as pi by 2. Cos 90 is what? Cos 90 is 0. So you have got log y as 0. Now you know that if log will be taken onto the right hand side, it will form e raised to power 0. So the value of y will become 1. I hope you have understood this topic well. And if so, then don't forget to like, share and subscribe my channel. Till my next video, take care of yourself. Bye bye.